Hi guys, I've been looking on the internet for very basic games to do a tutorial on, and I stumbled across this website which has about 49 ideas for games, which is pretty good. They're very simple and can easily be coded in pretty much one go. So today we're going to do a memory puzzle. It is a game that pretty much everyone played at some point. The idea is to have cards or tiles with an image on one side and nothing on the other. And then the game starts with all the cards being turned upside down. And you need to open two cards which have exactly the same image. And once you do, they will stay open. If you don't find the same image on the other card, then both cards close and you keep trying. So yeah, let's open up Eclipse, and you can create a new project if you want to. I'll just use one of the old projects and create a new package for this tutorial. Call it MP for memory puzzle. So we'll create a new class, call it memory puzzle app, which is the entry point to our application. And this is what we have. We'll be using pure JavaFX, so we won't need FXGL library for this tutorial. Extends application, you'll need to import application and implement certain methods, in fact just one method. And in our main method, we simply call launch which starts the JavaFX application. I decided to code real time because that way you can easily see what's going on, and for beginners I think it's the best to see the code being written rather than staring at the code that's already been written for you. But however, this has a disadvantage because coding real time means I write the first thing that comes to mind, which is probably not the best solution, or not always anyway. But at least it gives you an idea of what kind of problems you might encounter while coding, while doing games development. Right, in the start method we would like to call our primary stage and call show. Before that we'll need to set our scene, new scene with create content as the root, and we'll implement that method here which returns a parent. So this is going to be our root node, and we'll set preferred size, let's say 600 by 600. So this should create a window, a square window, and this is really what we need. I'm going to have a square puzzle. So first of all we'll need to create a new class for our tile or card. I'll call it tile, and it will extend stack pane because we're going to have a few things on top of each other. And in the constructor we will, so they're using images, and to keep things simple I'll use just others. So we'll need to take a character or a string will do, string value. So each tile will basically have a value, and then if the values of tiles are exactly the same, then we'll keep them open. So tile, we'll first need to create a border for each tile. A border can be represented as a rectangle with no fill, so I'll call it border. New rectangle, we'll make a square 50 by 50. So these values are the width and height of the rectangle. Also make sure you import JavaFX packages and not AWT. Border set fill null. This will remove all the color from the rectangle, and we'll need to add a stroke color black. Get children, add all border. We'll also need to add our text value. So text, new text value. Text set font something bigger, like 20, 30. And we'll also need to align everything to center, set alignment, position center. So this will center everything within the stack pane. Now we can create a tile. New tile A. A is the value of the tile. And we can add this to the root node, so that it is placed in the scene graph and shown on the screen. Yeah, so we have our tile, just a single tile. We'll need more of that, and we will also need, first of all, let's just create all the tiles that we need. So price static final and number of pairs. So we'll need, let's put 8, and then we could have, that means 16 tiles, and then we could make a square, so that gives us 4 tiles per row. Number per row is 4. We won't need that part because we'll create a list of tiles, so we'll need a list to keep our tiles. New array list. We need to import util list. Now for number of pairs, we create a tile. Right, we need to pass a letter, so we'll need something that holds the letter value and increases it. Character C, and we'll start from A. String value of C. So this is how we cast a character to a string. Or you could also do that. You're concatenating a character with an empty string, which gives back a string. So pretty much exactly the same. And we will need to add that to the list of tiles. Actually, we could do just that. Tiles, add. Now this is number of pairs, which means that we would need to do this one more time so that we have a pair in the list. And after that, we need to increase the character. So plus plus operator on characters will increase the value, which means this will become B, C, D, so on. So basically using the alphabet, as opposed to integer values where plus plus would increase the value by 1. So it does technically increase the value by 1. Alright, so now we've added our tiles to the list of tiles. We will now need to shuffle them so that they're not in order. You can shuffle lists using static method in the collections class. Just call shuffle and then pass the list object. Now we need to display them. So for int I number for row, actually we'll go through the list first. Tile, so we obtain the tile at that position, and then we place the tile where we want it to be. So translate x, because its width is 50, so we're going to use 50 multiplied by index modular division by number per row. And tile set translate y is almost the same, but we're doing integer division now. This will place those things in row, and you'll see how that works in a minute. Tile, we now need to add them to the list of tiles, or to the scene graph. Okay, now we should have, now we have a sort of board of tiles, and it also shuffled them, so that's pretty much what we need. You can increase the number of pairs and use different value for number per row if you want to make the game even more difficult. So now we need to be able to open and close them. So basically we need to be able to flip the card or the tile. So we'll need a few methods here in the class tile. Void open and close. So instead of actually turning the tile, we could simply have the opacity property of text set to 0 or 1 depending on what we want. So I'll just take that out here. And instead of creating the object, we'll just set the value of the object. Text set text value. So by default, everything must be closed. So we'll call close when we start the game, or when we create the tile. Sorry. In the close, we need to set opacity. Actually, we'll do this using a fade transition, so it kind of creates a cool effect of fading out. New fade transition, duration, seconds, 0.5. half a second should do. And we're transitioning that object. So we need to import that as well. ft set to value. We're closing, so at the end we should not be able to see the value, which means set to value 0. So this will, when the animation ends, the value of the opacity of text, so this object will be 0. And setting opacity to 0 means we won't be able to see it. Yeah, so when we create a tile, or the tiles, they disappear. Now we need to be able to open them. So it is essentially the same animation that is played back. So instead of 2-0, we're going to be playing 2-1. Alright, we also need to be able to trigger open method, which means we need to set on mouse clicked. So when the mouse clicks one of the tiles or the area of the tile, then it will open. And then when we click tile, it opens, and it opens with an animation of fade transition, which gives this nice effect of fading in. Now we need to be able to open only 2 at maximum, and we also need to remember the one we opened so that we can check against it. I think we're going to have a reference to selected tile. So by default it's going to be null, nothing is selected. When we click the thing, we also need to ensure that if it's open, we do not click or it does nothing when it's open. So we'll need to have a method that checks whether it's open or not. Is open return text get opacity equals to 1. So if it's opacity, if the opacity property of text is 1, then it's open. So it should return true. So if is open, then we simply return there's nothing to do. Else we open it. Now we have selected reference, which means we also need to check against it. So if selected is null, then there is nothing selected at the moment, which means we now need to open this tile. So we can open the tile, but before that we set selected as this object. So we assign this tile to selected, so that selected is no longer null and points to this object. Else, that means selected is not null, so some tile has already been selected, which means that we need to check against that selected object. We could have another method that says that returns true if they are the same value. So has same value tile other. Return our values based on the string value, which is the text property of our text object. So we return text get text equals other get text other text get text. So this should return true if they have the same value. Has same value. Alright, else if so if it doesn't have the same value, if has same value selected, so we're checking against the selected object. If it's not the same value, then we need to close it, but we cannot really close it instantly because we need to first open it so that the user sees what the value is. Okay, we'll probably need to have a runnable here to pass runnable, which is the action to be played after the thing has been opened. So setOnFinished action run. So we're calling open method with an action which is executed when the tile has been completely turned over, so is now completely open. In this case, we don't really need to do anything, so we'll pass an empty runnable. So this is a lambda that creates a new runnable and that has nothing within its run method. So it basically does nothing. In this case, however, we first need to open it and then see. So once it's open, we now can check if it has the same value. If not, then we close selected, close, this close, in both cases, whether it's same value or not, we need to nullify selected because we've done what we needed to do, and this should run, I think. Yeah, let's just try and see what happens. So we click one thing, it opens, we click on it again, nothing happens. Because of this check, it's now open, so nothing should happen. We click on another, and because it's not the same value as the one that we clicked before, they both disappear. And if it is the same value, it stays open. Right, that's not bad, I suppose. Yeah, as you can see, my memory is quite bad. So I decided to do a 4x4. Alright, what happens if we click on everything? Alright, we got an exception. That traces back to has the same value. Yeah, we probably need to limit the number of clicks somehow. Okay, if we have a click count, click count 2, because we basically are checking the two things at most. Click count, and this is where the click actually happens. So if the click, so if it's open or click count reached 0, then we return, we don't do anything else. We need to restore click count. We need to first of all reduce decrement click count at this point. Now, at some point we need to restore it back to 2. So if selected is null, this is the first case when we just open the stuff. And this is the case where the second click happens and the actual check happens, which means we need to restore it here to 2. The event handler is actually getting pretty big, so I'm going to create another method that says handle mouse click, which takes mouse event. Make sure you import mouse event from JavaFX. And we'll place that code right here. And we will pass a reference to the method handle mouse click. That should do. Yeah. So whenever mouse click event occurs, it will call this method, which is right here. Right, so we've implemented click count, and now it should endure our mat click kind of thing. Yeah, it seems that the error is gone now. Yeah, I actually quite like that fade effect. It's really nice. And those values don't actually have to be letters. You could have full strings if you want to, because we're comparing to strings really, not characters. And you could also have images, which could be an extension to this tutorial if you want to. You could also increase the value of squares. So by doing number of pairs 16, this gives us 32 squares. And what about 4? Or yeah, 4 should do as well. So you now have 32 squares. Or you could use the whole alphabet. What was it, 26, 28? Yeah, so basically you now have a game of a memory puzzle game, which is just about 126 lines of code, which isn't bad. And I think that'll be it for this tutorial. Thank you for staying with me for the whole tutorial. If you have any suggestions, just leave them in the comments. And thanks for watching.